Okay. All right. Hello, everybody. Welcome to Open Source Antibiotics Series 2, October 9th. And let me just start out by saying hi, but also I'll share screen, which will be my browser. Hopefully that's the right one. So you're seeing metabolic clearance data, hopefully?
Yep.
Right. And the window's moving, hopefully?
Yep.
Okay. So this was the agenda. Thanks, Ed, for putting that together. That's really good. Pretty sure that there's a sort of little mini updates, and then we'll talk about chemistry. So just to summarize again, the mechanism of action stuff is ongoing by Lee Graves in his lab, and we'll chase up in maybe a week or two or something, make sure everything's going. But they said they'll get some results back from their experiments towards the end of the month. So nothing for us to do, I don't think. But obviously, really interested in what they'll find out. And then the in vitro PK stuff that we got back, that we talked about last time, has highlighted that this benzofuran compound, rather than benzothiazole, is of interest to us for metabolic experiments because it doesn't get cleared too quickly.
I think it was a benzothiophene.
Sorry, did I say thiazole? Benzothiophene,
Yeah.
sorry. Yeah. So we had suggested that 822 would be the one to send, but clearance is so fast that we thought maybe the benzofuran would be better because it's more typical, which is good. So I've just corresponded today with Haifa about sending that compound, and hopefully we can just get that paperwork done in the next few days and send off that compound. So that just raises that one residual question, guys, about stocks of 821. Is that all right?
I've just remade it, so I've got about 75 megs of it.
Awesome. Okay, I'm pretty sure that should be enough. Yeah, that's great. And when we've signed the paperwork about that, then I think I can talk more about what they've agreed to do, which is really good. Okay, so that's helpful for that compound. There was, as I was just saying before we started recording, there's uncertainty about the data that we've inherited. I don't know the way this is so, I find it so amusing with little tiny things like this, but we've got the data presented in the table there, and it's quite nicely agreeing between two different data sources. So some of the original data we inherited was from UNC, and then the more recent data is from Monash. And so the start data here, for example, these two numbers here, and the mouse data over here were from UNC, and the more recent data has the little cross on it from Monash. And obviously there's sort of decent agreement there where we tested the same thing. But the units are different for each, unless I'm going mad. So in one case, the UNC data came back with the Clint value at mil per min per kg. Monash data is microliters per min per mg, which doesn't match. It's 10 out, right? Because there's, unless I'm going insane, there's 10 out. So I was just thinking about what the data source was for the UNC data. Does anybody remember? Because I had some of this data in the grant proposal, but was there a primary document that we had somewhere?
Yes, it should be on GitHub. It was sent to us by Bill, and I do think that they used a CRO. I can't remember the name of it, but it's in the repository.
Okay.
And I think there's 3 different docs, depending on what compound and whether it was mouse or rat or something. So.
Right. Yeah. No. The units are different, which is quite interesting.
Yeah, it's those 4, the MLM, MLM, RLM. Yeah.
Okay, so we don't need to do this now. We can have a look at it after, but I think we do need to just go and check that. I was interested. I was going back and checking open source malaria data. Actually, it's kind of interesting to see what we did from there, because of course we work with Monash all the time, and there again the data is presented. I don't know if you can read that; it's pretty small, but the units for the clearance are microliters per mil per mg there, or mil per min per kg for rat PK. So there's some different unit for rat.
Well, one of them's in vitro, and is the mil per minute per kilogram for in vivo.
Yeah, okay, so it makes more sense, I suppose, but I guess I'm surprised that we have this issue in the in vitro.
Yeah.
So we've got to figure it out, just because, I mean, it's a tight and niggling little thing, but we've got to be able to compare the data, because obviously at the moment they match very nicely, kind of.
Yeah, I mean, if we just even had like bins for the UNC data, like what they would use as high, medium, and low, then it would be probably helpful to
Okay.
that way.
Okay, but I have to leave this on this the to-do list, because we got to make sure we're not missing something.
Okay.
In any case, I mean, I'm very happy with the original. Sorry, with the Monash data. I mean, there's no reason to be worried about it. So because we, as I said, we use them all the time, and we know what we're dealing with in terms of high, medium, and low, and so on. Anyway, so the upshot of that is that 821 is kind of our interesting compound, and it's very useful. It has a pretty average clearance for this set of compounds, and yet it still has the potency, which is good. Okay, what else? So yes, the next screen of compounds, it's meant to be happening about now. We're just checking in with Paul Stapleton about when that is. I haven't had a reply from him. I'm guessing you haven't either, Dana?
No,
Okay.
I think I emailed him, I don't know, Tuesday or Monday or something, earlier this week. Yeah.
Okay. And also the toxicity. So that's a green light, isn't it, for toxicity, for measuring that, and again in the short term in the School of Pharmacy, right? Because we're talking with Andreas and his student about that.
Yeah. So I'm just gonna chat with the postdoc and I think the grad student that's training under them on Monday.
Awesome.
Yeah, and just get sort of more info about what they plan to do and what their capacity is and things like that. So
great.
Do
Okay.
they know what cell line they're going to use? I was thinking maybe human fibroblasts, because MRSA infections usually start out in the skin. So that would be good to know.
Yeah, I was going to ask them that.
Okay, we'll come back to cytotox in a minute. Obviously the other thing about the donation of compounds, just on that basis, they've all come in now. I think I saw the imperial compounds are in. So that's everything, which is really good. So the approximate number of compounds that's going to be screened next week, if the assay is running, is what, 35 or something?
I think so, something like that, between 30 and 40. Okay,
which is great, obviously.
Yeah.
I mean, there's a heavy bias there towards some of the compounds which Ben has donated, obviously, but that's an important set. All right, biofunctionalization is the HIFA thing. The similarity landscape, still nothing from GSK, but I'm just I keep on just sending polite emails to ask if I can talk about what was known. I'll just wait to hear back. And then this video for you guys to do. You want to write it down, maybe on your hands, or on a cap or something, a t-shirt. All right. Well, again, doing a little. If we're doing some screens next week, maybe video in the lab. Be amazing. All right, the original COAD report. So Bill Zurcher finally very kindly got back with the original COAD report on these compounds. So I'm going to just switch over to a different window. So I've uploaded this, and obviously it's an important one. So what am I doing first? I'm doing, I forget which one I'm doing, sorry. So I'm sharing this window. No, that's the dose response thing, isn't it? So I want the one that isn't diarrhea. Sorry, hang on a second. So I want.
Quick thing before about COAD.
Yeah.
Seems like they don't screen against S. pyogenes, which is what I was thinking would be a nice gram-negative to test against too, because it does also cause similar infections to Staphylococcus aureus.
Oh yeah. I mean, yeah. This is. I mean, it's a platform-free service. That was the idea.
Yeah. So, do you know if Paul Stapleton would be able to screen against S. pyogenes?
I don't know, actually. I'm not sure what he runs habitually. I think the Mercer is the one he tends to run. But yeah, no harm in asking if there's something else that could be run for sure.
Yeah, Streptococcus pyogenes.
Okay. All right. If you could just pop that in the.
Yeah, I did.
Okay.
Yeah, because that's another gram-negative that also causes soft tissue infections. It's the cause of strep throat and also necrodental fasciitis.
Okay. I mean, the thing that's notable from this, obviously,
Is that there's no inhibition of any gram positive?
Yeah.
Oh no,
Yeah,
it's
like-
the reverse.
Oh, it's the other way around.
Sorry.
Yeah, yeah.
I mean, it's
I'm never good with
completely,
bacteriology.
G.
Yeah, G positive. Wait, hang on.
So I mean, it's-
Gram, sorry, gram positives are inhibited, not gram negatives.
so the interesting thing for me from this data set here, a little bit, was that there was this, fairly clear activity against some of the fungi, which didn't pan out when I switched to the other sheet. I guess, so this is why they do the MICs, obviously. But here are all the structures, and here's what found. So they were very, clearly active against MRSA and really not much else. So at least we have the, sort of the numbers for that. And then I guess the main thing is there's lots of details here about what the numbers were. But then when they did the MICs, which is what I just need to switch to. Sorry, 1 second. Both the Excel sheets look very similar in this thumbnail mode. Okay, here you go. So then, again, this sort of confirms the activities that we saw. So here are the numbers that we inherited. So everything's fine, right, in terms of the SIR that we have on the wiki. But the thing which was new for us, which we wanted, was column N, which is the, can you see this? Which is the, that's the cytotoxicity. So method analysis here, the assay is human embryonic kidney cells. So it's just the HEC293. And, those numbers they're not fantastic, right? Because this is not a very big window of opportunity.
So I went back and checked their definition of MIC because I realized I didn't have a good handle on that. So it's a minimum inhibitory concentration, which shows full inhibition, which they defined as greater than 80%. So I think, the numbers I think probably maybe are a little bit, the window's a little bit better than maybe that we think it is, right? Because an EC50 would be less than the MIC. And this is a CC50.
Okay, I think I understand that.
So yeah, I think it could be better, but it also could be a little bit better than it looks maybe at first glance when you think about the MIC being 80% inhibition.
Yeah, there are probably worse antibiotics out there, like aminoglycosides, for example. Quite cytotoxic, but are still used.
The thing is, though, you're talking about bringing a new compound to the market, so you're going to have to be better than everybody else.
Yeah. I guess, yeah. I guess I wasn't clear about how much of a red flag this is. It's a number we want to improve, but I wasn't quite sure how much of a red flag it was. I was also a little bit perturbed by how constant that value is throughout, in the sense that something not great is happening, and it seems to not really change when we look at all of these different compounds. And that just slightly concerned me that there's, essentially flat SAR on the cytotoxicity.
Plus, maybe when we figure out the target, that can help us a bit.
Yeah, sure. So the one constant, I think, which I can't remember if it was Eucharis or Ben that was pointing out the danger of methyl chelation between the two nitrogens as being something that's potentially problematic. I think that maybe he was mentioning that in terms of cytotox when he was originally questioning the values that we had. And that is the only constant here.
So
yeah.
It would be interesting if you were to move the nitrogen around the pyridine ring, even if they're not active as antibiotics, test them in the cytotoxicity assay.
Yeah, fantastic. I think
I
that's.
was gonna say just swap the bottom ring for a phenyl and see it's probably gonna be inactive, but see the cytotox.
Yeah. Yeah, so that's what I take from that. I'm just going to make a note. That's the crucial one. And of course, we have that compound, or we have those compounds in train, right? We have compounds already or coming that lack.
Actually, wait a minute. So you compound 20 there, then that is the 3-pyridol. Is that right?
Yeah, but it's got the methylene dioxy.
Yeah, but it would still have the chelating bit, wouldn't it?
Yeah.
Not evaluated here
Oh, okay.
because it was inactive, I think.
Ah,
So there's a good point. We shouldn't get distracted by the the Mercer activity. We should test them anyway.
Yeah,
Yeah.
cytotox, we should definitely try the one, Ed. I think you made the one with the phenyl on the bottom.
Yeah.
So that could be definitely interesting to see cytotox-wise.
So maybe if we have those for the screen that Andreas is doing, we should get them straight in there.
you should test a few of these as well, just so
Yeah.
that you've got positive controls, as it were.
Yeah. Just to verify.
Because if it is metal chelating an activity and that's toxic, then there are ways to mitigate that.
Unless that's the mechanism of action of their antibiotic activity.
That would be annoying.
That would possibly be a showstopper, wouldn't it?
Yeah. But the fact that you get, it looks like, as you said, Matt, that constant activity in your toxicity, but you're getting a order of magnitude difference in activity in your antibiotic activity.
Yep. So hopefully.
Yeah, there's hope there, I think, anyway.
Anyway, good that we've got it. I mean, I'm pleased to get that. I mean, just as a note here as well, these data and these compounds were obtained by our friend Alvaro, who isn't on the call today. But I just want to make it clear that when we have things like this posted to the site, as I think we have done, we acknowledge the source here, which was part of the original project with Bill and Alvaro, which is why they're both still involved, of course. Just to highlight that.
Yeah.
All right. Good. So I'm glad we got that, but definitely an action item for us there, which is very useful. And then just going back to these thumbnails, really don't. Okay. Are we back on this page that I'm moving? Okay, fine. All right. I did want to make sure I'm not, going to my email basically by accident. All right. So that's great. We can pursue that. Got my donations, and then I guess we're thinking about synthetic chemistry. Oh, just on the AOB here. Yeah, Dana, you've already asked Paul for both these things, and we're waiting for a reply. So I guess I need to follow up on a bunch of things that we're just waiting on Paul for, right? We're at the not perfect storm. We're at the moment now of first kind of teaching week, so it's a little bit busy for some people who are preparing teaching materials. But
in the waiting room, yeah.
This is Okay, I'll stop sharing. If you wanted to talk about some chemistry, is that all right?
Yeah.
Great.
Okay, so this is essentially a summary of stuff that hopefully will be ready for next round of screening. So 144 I've already talked about. I also made that core with the benzofuran on it, since we're looking at that in the other cores also. Then it made a couple of the phenyl derivatives. So just the plain phenyl I've already talked about. And then I've got the 3-fluoro. I tried the 2-trifluoromethyl, but that Suzuki did not go at all. And then the indole. So basically we have the sulfur and the oxygen at this position. So I thought I might as well just try the nitrogen as well. So hopefully those should all be done by early next week.
Cool.
Also, I think methylation of that indole shouldn't be too hard.
Yeah, we could try that too.
Clark methylation.
And then, yeah, so my stuff, so this is 81, so I remade that. And then I've also made the benzofuran versions of the 3 and 4 pyridine, and then the one with this pyrimidine. I think I need to repurify that, but I'll probably get a few mgs out of that. And then there's this 3 cyano one and the paramethyl, just because we had those boronic acids in the lab already. And then this one that Anthony suggested, so I've bought some of that. So that should come in sometime next week, I think.
Awesome. Great. Okay, all of those are nice. Yeah. All right, yeah, and thanks for doing the search, Anthony. Very useful.
No problem.
All right, nice, great stuff. Thanks. There are also the suggestions from last time from Ben about the Negishi and things like that. But I guess that's just, I'm going to leave that there just because it's kind of interesting.
I looked into the Negishi and I found a paper that looks like a pretty nice one-pot procedure. I just had to order something for it, so I haven't done those reactions yet, but I will be able to try them.
Okay.
I also did a literature search and tweeted at Dan about a very interesting looking alkene Sangoshira coupling using TBAF hydrate, which is a interesting thing, but I'm pretty sure most people stock that in their labs.
You tweeted it.
Yeah.
I found it. I just haven't given it a read yet, but yeah, I will do that.
Yeah.
Okay.
Uses TBAF hydrate, which is a common lab reagent, I'd assume.
All right, good. That's all good. So yeah, we are ready for potency and maybe hopefully some cytotox next week, which is great. Anything else anyone wanted to mention? I mean, I think we're covering everything.
No, but I put the name of the microbe that I'd be interested in seeing if it also works against strep pyogenes. I don't know what Paul's. I don't know. Is Paul Stapleton a bacteriologist or what?
Yeah, he was a microbiologist.
Yeah, so he should be able to hopefully do a run on that too.
Okay. I don't know why I can't copy things from the chat window anymore. I think it's like a security thing, right? But I can't copy it.
It's Streptococcus pyogenes. It's
Yeah, no, I'll
very well known. Causes strep and causes strep throat, which we've all probably had as a kid, and also necrotizing fasciitis as well.
Yeah, I checked the WHO priority pathogens list also, and there are only 2 other gram positives on it. But if we wanted to look at that, we could also. Those are options.
What are the other 2? Because I was just off the top of my head, I just said S. pyogenes. Why not? Because that's no fun.
Oh yeah, Ed's got the list, so I can.
You're muted. Maybe you want to be.
Oh, he closed it. Never mind. I don't remember exactly what they are, but I'll follow up on the minutes.
Yeah, I mean, if you could, because I mean, on top of that, we have to think about if there's somewhere we could get them evaluated if we're interested in doing that, and that's not.
Yeah, right.
We don't know what the. It could be this thing could be inhibiting some sort of cell wall enzyme in such a way.
Who knows?
The differences could be causing. We'd have to wait for MOA to see, wouldn't we?
Well, yeah. I think usually the issue with stuff that's gram positive but not gram negative is penetration of I think it's the peptidoglycan layer that gram negatives have and gram positives don't. So that usually is the issue. It's just getting into.
Yeah, I mean, the MOA stuff can help reveal us a little bit, on the if it's an accumulation issue as well.
Actually, Streptococcus species are on WHO priority.
Yeah, there's
both
2
Pongier and pyogenes.
Okay, maybe what you find, just post it in.
Yeah, I looked at the WHO. Yeah, it's on there. It's on the low priority list, but not considered high priority.
Okay. If something's promising, then please try and just see if anyone's got a screen running, because that would help. But
yeah, definitely.
these things are sometimes tricky. All right, great. Thanks very much, everybody, for your time. Really useful. I'll post the recording as per usual and talk soon.